Hey yo, what's good? YouTube is your boy JOHHABRAHA. And yes, we're back with the uh, with the introduction to general chemistry, and we're continuing with the periodic table. Now, what the fuck is a periodic table? I don't know. It's a table. It's a table. It's a lot of shit, lot of stuff going on. Periodic table of elements, ancient times. Wait, we had 42 elements, then we cut down to 18, then 11, 17, 15. What? What? 15 elements? I don't get that. Why 15? This is not 15. Periodic table of elements. Should I have to look into the past? Dmitry Mendeleev and Lothar Mayer, 1830 to 1895, 1869, both independently presented the first PTE. Elements were listed according to the increasing atomic mass, and chemical and physical properties are repeated periodically. So, difference. What? What is this? Wertig? God damn, I don't get it. Periodic table of elements, atomic comparison of the properties of ecosilicon. Oh, okay. This guy predicted, right? Some shit like that. Ecosilicon predicted by Mendeleev with the observed properties of germanium. Let me just wash my hands, wash my eyes. Measured X-ray emitted by atoms. Henry Moseley. Measured X-ray emitted by atoms. X-ray emitted by atoms after bombardment with high energy electrons observed that frequency of the X-rays increased with increasing atomic mass. Arranged X-ray frequencies in order by passing a unique number called atomic number. Atomic number was identified as number of protons in the nucleus. The effective nuclear charge is defined as, whereas S is so-called shielding constant. Periodic table of elements. Periodic table. The elements are arranged according to the increasing atomic number, where elements with similar properties, similar electron shells, are summarized to vertical groups. Vertical. The periodicity of properties results from the fact that electrons are organized in the electron shell according to the periodically repeating pattern, electron configuration, increasing metallic character. If we're talking metallic character, paramagnetism that I discussed yesterday could be factor. said I set a timer for 30 minutes. Okay. What's the tomorrow's timetable? Instrumental analytical chemistry, okay. God damn it! So S block, D block, P block, F block. Oh, okay. These are filled on the S orbital, D orbital, P orbital, P subshell, F. Oh shit. Okay. Sulfur. Sulfur goes here. Yep. Mm-hmm. Mm-hmm. So F block configuration for chemical reactions, primarily the electron configuration of the outer shell valence electron is of the importance. As they have identical configuration in the outer shell, elements of the same group show similar chemical properties. For this reason, it is common to use shortenations by adding preceding noble gas elements as square brackets. For example, this would be neon with an electron configuration. Sulfur, we could write it in this way. Yes, that makes sense. Periodic properties of the elements. Within each group, bonding atomic radius tends to increase from top to bottom, top to bottom, top to bottom. This trend results primarily from increase in principal quantum numbers of the outer electrons. As we go down a column, the outer electrons have greater probability of being farther from the nucleus, causing the atomic radius to increase. Within each periodic bonding, atomic radius tends to decrease from left to right, decrease, okay. Although there are minor exceptions such as chlorine, argon, arsenic, selenium, the major factor influencing this trend is the increase in effective nuclear charge Z effective across a period. The major okay, the nuclear charge increases from left to right. That results in the reduction of radius. Why is the effective nuclear charge increasing? With the increase in atomic number, which results in more protons inside the nucleus. That's what I believe, I guess. The major factor influencing this trend is increase in effective nuclear charge. The increasing effective nuclear charge steadily draws the valence electrons closer to the nucleus, causing the bonding atomic radius. Increasing effective nuclear charge, valence electron. Okay. Anions are generally larger than neutral atoms, as additional negative charge leads to expansion of the electron shell. Cations are distinctively smaller as the nucleus has less number of electrons to pull in. Okay. What kind of songs are these, bro? Why? I opened it here, bro. Come on. Come on. Oh, bro, come on. Just a minute, YouTube. I just gotta one thing. Perfect. Periodic properties. Now, this is radius, right? Downwards, radius increases. Left to right, radius decreases. Okay, that makes sense. Okay, okay. Oh no. Periodic properties of elements. The first ionization energy of an element is the minimum energy required to remove the first electron from an isolated gaseous atom, thereby forming a cation. First ionization energy of an element is the minimum energy required to remove the first electron from an isolated gaseous atom. Periodic properties of the elements. The first ionization energy of an element is the minimum energy required to remove the first electron from an isolated. The first ionization energy of an element is the minimum energy. Okay, okay. First electron from the isolated gaseous atom, thereby forming a cation. Okay. In the same way, also a second electron can be removed, whereby okay. Noble gases are hard to ionize. Generally, elements at the bottom of the left of periodic table easily release an electron. Okay, electrons with higher radius has is easier to release an electron. Elements at the top right are the hard to ionize. Top right, helium. Yes, helium is one motherfucker. Yes, with the smaller size, higher energy is required. It's just the opposite of this one, right? You could just take this one, put it above this. It's gonna fill in. Nah, not exactly. Cause look at this part. Nah. Ionization energies show an opposite trend compared to the atomic radii. The larger the radius, the lower the first ionization energy. Ionization energies decrease within a group as the electrons are farther away from the nucleus. Ionization energies increase within a period. Okay. Ionization energy opposite trend. Yeah, larger the radius, lower the ionization energy increase within a period. Ionization energies increase within a period. What is a period? What? Periodic properties of like elements. Successive values for ionization energy for the elements sodium through argon. Or sodium. Sodium. Where's argon? Yeah, okay, here. Sodium, magnesium, aluminium, silicon. Okay, okay. Difference between N and N plus 1 ionization energy for selected elements. Na removal of second electron requires, yeah, I get that. Periodic properties of elements. The electron affinity specifies the energy change observed when an electron is added to an isolate. What? Electron affinity specifies the energy change observed when an electron is added to an isolated gaseous atom, forming an anion. Mm-hmm. Mm-hmm. I also need to check one thing. Mm-hmm. Hmm. Mm-hmm. 10 assignments. When an electron is added to the isolated gaseous atom, forming an anion. So, do we give in energy to put an electron? Yeah, I believe so, right? Yeah, negative means we are giving an energy. There's not such a clear trend as for ionization energy, but in general, elements situated in the upper right corner take up electrons easier than those of the left. Okay, yeah, it makes sense because because the if the radius is higher, if the radius is higher, it would be harder to put in an electron, but if it's lower, it's easier, I guess. Dude, no way I just completed periodic table part. Chemical bond. The chemical bond, two atoms or ions are held together by a chemical bond. Chemical bonds are regarded as strong interactive between atoms. In establishing a bond, so called valence electrons play an important role. Valence bonds electrons are found in the outer shell in often not fully occupied orbitals. A graphic representation of the molecules with respect to their valence electrons are given in the so called Lewis structural formulas. One reason why a chemical bond is established lies in the so called octet rule. In a strict sense, applies to the elements. Thereby, atoms tends to lose, gain, or share electrons till they are surrounded by 8 valence electrons. Yeah, I do remember the octet rule. So they try to obtain the electron configuration of noble gases with fully occupied orbitals in the outer shell. Okay. Covalent bond, ionic bond, I do remember these. Okay, chemical bond is pretty big, okay. I have to complete chemical bond within 139 chemical bond within this. Come on, this Saturday. It's 7, but no, it's not actually 7. I still got 6 more minutes. Okay, now, think, Josh. I gotta write the periodic table. Electron affinity. It's cold, it's cold. It's cold. What's with the cold? I don't get it. I don't get it. Darling, so cold. Someday, so meant to be. Two. Mm-hmm. The lithium and hydrogen, they both. Wait, one S, two. Yeah, one. What's helium? Okay, okay, get it, got it. Got it. 30 minutes? God damn it. I'll write for the periodic table tomorrow. Okay, okay. According to my timetable, I gotta be looking into biochemical kinetics. YouTube, I'm gonna end the stream. I'm gonna restart like right now. Peace.